New Street Station in the heart of Birmingham city centre. With 12 platforms, 630 trains a day and 48 million passengers each year, it is one of the busiest stations in Europe. Following a safety review, £11 million was invested over a 3-year period to improve fire precautions and passenger safety. The monies were generated through the joint sponsors of the project: Intercity, Regional Railways, Centro and the European Fund. Included in this programme was the provision of a new footbridge and ticket office, which has improved egress from the station in the event of an emergency and at peak times. Architects Pant and Sargent were commissioned to produce a futuristic design for the footbridge, and it was left to Regional Railways Civil Engineering Design Group, based at Birmingham, to translate the architectural concepts into design reality. The main body of the footbridge is formed by 3 main spans, each 5.5 metres wide, 4 metres high and 20 metres in length, plus one smaller span, 2.5 metres wide, 4 metres high and 10 metres in length. Other major steelwork structures included the stairway accesses to the platforms and spectacular glazed canopy roofs, or kites, which let natural light into the entrance and stairwell areas. The entire superstructure was finished in an enamelled steel cladding and featured curved glazing in the staircase towers. The unique location of the bridge required British Rail's design engineers to assume a method of construction for the bridge as a basis for their design. This assumed method was included in the tender documents for the contractors to adopt if they wished. Miller Civil Engineering, who were awarded the contract, examined various methods of erection, but concluded that British Rail's was the most suitable. The project posed a number of specific problems. British Rail's design engineers had to take account of the necessity to keep disruption to passengers to a minimum. As all 16 lines at the station are electrified with overhead power lines, many of the major stages of construction could only be conducted during possessions. Thus, the design team had to take account of the possessions that would be available and make decisions as to what work could be carried out during these limited periods. Secondly, the city centre location severely restricted the working space adjacent to the site. The roads around the site were major bus routes, and large volumes of pedestrians moved through the area, which was on the fringe of a busy retail sector. Discussions were held with Birmingham City Council, local bus companies and other interested parties in order to work together to minimise disruption. Again, the closures that were possible and the space available had to be incorporated into the bridge design and construction method. These factors ruled out piecemeal assembly on site. Each span would have to be placed in position across the tracks as a single entity. This posed a further problem. Because of the weight of each span and the reach required, it was not possible to lift the main spans in by crane. Thus, there was no alternative but to launch the main spans out over the tracks, supported on temporary steelwork. Then, when in position, to lower the entire structure 3 meters onto its permanent foundations. Having adopted the designer's construction method of launching the bridge, the contractor, Miller Civil Engineering, were left to determine the detailed aspects of the construction process and to manage the project under the demanding conditions imposed by the city centre location and British Rail's insistence in maintaining New Street as an operational station 24 hours a day. The lack of space adjacent to the site resulted in the operation being spread over 3 compounds. Compound 1 was established in the car park of Stanier House, British Rail's regional headquarters. This was located some 400 metres from the construction site and housed the site offices. It was here that the main spans were assembled. Compound 2 was established outside the British Rail Signal Centre on Navigation Street. And Compound 3 was the launch site. It was not possible to fit the top cladding to the spans in Compound 1, due to the height clearance required for the Suffolk Street Queensway flyover. Assembled spans were transported to Compound 2, where cladding and painting was undertaken, before being transported the final distance to the launch compound. Road closures and police escorts were necessary for all transportation movements. The permanent concourse floor slab was constructed early in the programme, so that it could be used as an extension to the launch platform, enabling 2 sections to be launched together. At the commencement of the first weekend possession, 2 completed spans were in the launch compound, and a third in Compound 2. With a possession from 9 o'clock Saturday night until 5 o'clock Monday morning, there were 32 hours to launch Span 1. The first stage was to manoeuvre Span 1 into position with the assistance of a 500-ton crane. The span was then winched forward, out over the rail lines onto temporary steelwork. The temporary steelwork was level with the launch platform, and some 3 meters higher than the bridge's permanent bearing positions. The launch mechanism consisted of 2 winches connected to the span through a rope and pulley system, with a third winch acting as a restraint mechanism. This configuration enabled left or right deflection of the structure, so maintaining correct alignment. On the second weekend possession, Span 2 was lifted into position and spliced to Span 1. The entire structure was then launched. The spans were pulled over rollers at a rate of 1 meter every 3 minutes. Accurate alignment of the spans was a crucial factor, and their progress was continually monitored. Theodolites measured the deflection of targets fixed to the steelwork and relayed information to the launch engineer directing the winching operation. Once the first 2 spans had been successfully launched, the third span was spliced on, the ropes reattached, and the entire 60-meter structure launched out. Two weeks later, again during a weekend possession, the bridge was ready to be lowered the final 3 meters onto its permanent supports. This was a delicate operation, as once again alignment was critical, uniform lowering being essential in order to prevent twisting or point loading of the structure. The lowering operation utilized 4 double-acting hydraulically controlled 50-ton jacks connected to a hydraulic power pack and control system. The bridge was supported by 4 sets of steel ropes passing through the body of the jacks. Any combination of jacks could be lowered, but generally all 4 were lowered simultaneously. In this manner, the 60-metre, 116-ton structure was gently and accurately lowered and finally positioned onto its permanent bearings. Later, the 4th and final section of the bridge was craned into position from the opposite side of the station. With the steelwork in place, the task of finishing the superstructure and constructing the concourse building and ticket office could be completed. The works involved interfacing various disciplines: concrete, secondary structural steelwork, glazing, primary steelwork, and cladding. And internally, ceilings, electricals, handrailing, and tiling. Much of the work had to be done in possessions and involved the complex coordination of contractors and materials. The futuristic design of the bridge at New Street and the very restrictive access and working space available both in and around the station produced a series of unique problems for the British Rail design team and for the contractors, Miller Civil Engineering. The conceptual, structural and constructional design of the bridge were inextricably linked and required a major cooperative effort. And the result of that effort is an example of excellence in architectural and engineering design and construction that the people of Birmingham can enjoy for years to come.